Hello and welcome all students. I welcome all of you in this educational platform. Today, as far as theory is concerned, we have last session of the chapter chemical bonding, in which today I will discuss about the hydrogen bond. So I'll tell you what is hydrogen bond, how the hydrogen bond is formed, what are the consequences which came because of the hydrogen bond. What exactly role hydrogen bond play, I will tell you in today's session. So this is very important session, guys. Come and let us study about the hydrogen bond. So student, in this class, I shall teach you about the hydrogen bonding and the conditions under which hydrogen bond is formed. I will also teach you about the type of hydrogen bond, how many kind of hydrogen bonds are there, in which we will discuss about the intermolecular hydrogen bond and intramolecular hydrogen bond. One is inter, another one is intramolecular hydrogen bond. So what are they exactly? This we shall discuss in this unit. Now what you see, how this H bond is formed. What happens? Two different molecules of water, they come together. When the two different molecules of water come together, the negative end of one molecule attracts the positive end of other molecule. It is quite obvious that positive end of one molecule will attack negative end of the another molecule, right? It will result in the formation of hydrogen bond. Basically it is a bond, a weak van der Waals bond, physical force of attraction called as hydrogen bond. Now let us study some more about the hydrogen bond in detail in this class. Hydrogen bond is nothing else, it is just electrostatic force of attraction between covalently bonded hydrogen atom and one molecule of high electron negative atom like oxygen, nitrogen and fluorine within the same molecule, or it could be of another molecule, and this bond is called as hydrogen bond. It's a weaker bond as compared to the covalent bond because it is a van der Waals, a physical force of attraction like van der Waals bond. Hydrogen bond is represented by the dotted lines in contrast to thick line representing a covalent bond. Do you know what does it mean? When we represent a covalent bond, students, see in this HF molecule, this bond is covalent bond. So we represent covalent bond with the thick lines. Alright. But as far as the hydrogen bond is concerned, we represent them with the dotted line like these. So in this, there is an existence of hydrogen bond between two fluorine atoms. Alright. So in common terms, you can say hydrogen bond formed when hydrogen atom stuck in between two high electron negative atoms. That is the condition of the formation of H bond. Alright. Now, what do you think? What are the cause which forms the H bond? So the bond between hydrogen atom and a small but high electron negative atom such as fluorine, oxygen or nitrogen is highly polar. The electron negative atom tries to pull the shared pair of electron toward its own side, which results in the development of partial negative charge on the electron negative atom and corresponding partial positive charge on the hydrogen atom. Now because of this development of these charge, this hydrogen atom, which is now partially positively charged, will attract towards the another high En atom. Now the positively charged hydrogen atom of one molecule, it will attract the negatively charged atom of other molecule, which is obviously high electron negative, and the two molecules, they get linked together by this weak force of attraction called as hydrogen bond. So you should always remember what that hydrogen bond is a kind of van der Waals bond. It's a weak van der Waals force of attraction. So hydrogen atom thus act as bridge. Basically it is sandwiched between two electron negative atoms. So it acts as a bridge between two electron negative atom of the adjacent molecule like this. One electron negative atom is this fluorine and another is this fluorine, which belongs to two different atoms. When hydrogen atom stuck between them, this is called as, students, H bond. Alright, so I hope now you understood how H bond is formed and what are the conditions in which H bond will be there. Now another condition we shall discuss here. Hydrogen bonding comes into existence as a result of dipole-dipole interaction. What is dipole-dipole interaction? Suppose, the student, this is dipole. In this dipole there is a positive charge, there is a negative charge. This is another dipole. Again it carries positive and negative charge. So this species is dipole. This species is also dipole. And the force of attraction between them is dipole-dipole interaction. Moreover, attraction. So the condition for the effective hydrogen bonds are: number one, high electron negativity of the atom which bonded to hydrogen. See, whenever hydrogen atom bonded with any other atom X, if this atom X is high electron negative atom, only then this H bond will form. If this X is oxygen or fluorine or nitrogen, which are high electron negative atom, only then it will form H bond. See, chlorine never form H bond under the normal circumstances, but chlorine might form H bond as an exception in some examples where cyclization is there. And the another condition, prerequisite for the formation of H bond is small size of the electron negative atom. So the electron negative atom which forms the H bond should be of small size, otherwise H bond will not form. So like we discussed, high electron negativity of the atom, higher is the electron negativity of the atom, greater is the strength of H bond. This is important. This is important, students. So now we came to know and we learned a lesson that all H bonds are not of same strength. It is not like that H bond is always have similar strength. No. If the electron negativity of atom which forms the H bond is more, then H bond is more stable. Like you see, out of these three atoms, fluorine, oxygen and nitrogen, fluorine being the most electron negative atom, so the H bond which is formed between hydrogen and fluorine will be the strongest out of these three, between oxygen or between nitrogen. So like I said, electron negativity of fluorine, oxygen and nitrogen, it follows this order. So this order is also order of the strength of H bond. Like I said, whatever the order of this electron negativity, the same will be the order of their strength. Next factor was the small size. For an effective hydrogen bonding, for the good hydrogen bonding, size of the electron negative atom must be small. Why? So that it is able to attract the bonding pair effectively. If its size would have been small, then it will attract the bonding pair effectively and there will be more chances of forming H bond. For example, ammonia, it forms H bond, but hydrochloric acid do not form H bond. That's why? Because this is due to the large size of chlorine atom. Although chlorine and nitrogen, they both have same electron negativity over the Pauling scale, which is, students, 3.0. So electron negativity of nitrogen and chlorine as well is 3.0, but still nitrogen do form H bond, but chlorine do not form H bond just because of the large size. And due to the large size, low electron density. Electron density will also be low. Now, how many type of hydrogen bond we know? What do you think? How many type of hydrogen bonds are there? So basically there are primarily two kind of hydrogen bond. One is the intermolecular hydrogen bond. So students, intermolecular. What do we mean by intermolecular? Intermolecular means in between the molecules. In between the two molecules, you precisely you say. They might be similar or they might be of different type. They might be of similar type or they might be of different type. Alright, according to that they are of two type, homo and hetero. That we shall discuss later. So what is intramolecular H bonding? In this, hydrogen bond is formed between the two molecules of the same or different compound. So they could be same or they could be of different compounds. The molecule of the same or different compounds, they get polymerized and or they get associated. Because of this H bond, n number of molecules, different number of molecules, they get associated and also considered as polymerization. It can also be called as polymerization of them, right? Examples of compound which form intermolecular H bond. Please remember the name. It is intermolecular, inter, in between the molecule. Example is HF. We studied in the beginning of this class. Water molecule. There is a formation of water molecule, H bond in water molecule, but that too is intermolecular. Ice, ammonia, alcohol. So out of these compounds, in whichever example H bond is present, that will be of intermolecular. Say for example HF. See, this is one molecule of HF. This is another molecule of HF, and hydrogen bond do exist between them. This is in between the molecule, so it is obviously intermolecular. This is intermolecular, and moreover it is homo-intramolecular, because in this the two molecules in between H bond is formed. They are of same type. Both the molecules are similar. Now because of this H bond formation in HF, in solid state each HF molecule forms long zigzag chains which are linked together by H bond. So these chains are zigzag chains. Another example is water. 4 hydrogen bonds are formed by each water molecule. Please remember the number. In liquid, each water molecule forms 4 H bond. This question I have been asked in the competitive examination so many times. This central atom, which is oxygen, is tetrahedrally surrounded by 4 hydrogen atoms in the tetrahedral fashion. Hybridization of water is sp3, and these 4 hydrogens are arranged in the tetrahedral manner. Another example is ice. What happens in ice? In ice, each water molecule is tetrahedrally bonded to 4 other water molecule through H bond. The arrangement is extended to 3-dimension network, forming an open cage like structure. Open cage, because of the formation of H bond, you see the structure is open cage. What happens with the open cage? There is a large empty space. You see in this is what? Empty space. This is again empty space. This is empty space. So they have open empty space, and it looks like a cage. So structure of ice is also called as cage like structure, right? Now we shall discuss few examples of intramolecular H bond. But before discussing example, let us understand what is intramolecular H bond. The bond which is formed within the same molecule. Please underline the term. It is within same molecule. And what was there in inter? In between the different molecules. In between the two molecules. They might be of same or different type, but yes, 2 different molecules were there. But here in this intra, it is formed between the same molecule, between hydrogen atom and the same other electron negative atom of the same molecule. Definitely, when 2 different groups of the same molecule will form bond with each other, it will result in cyclization. There will be a formation of cycles, and this kind of H bonding is more frequently found in the organic compounds. It is more common in the organic compounds. See, you take this one as an example. You know, students, what this molecule is? Do you know what is the name of this molecule? Yes, you are right. It is phenol. Now, what about this one? What happens when in phenol one nitro group is introduced? When this nitro group is introduced, it is called as nitrophenol. Since this nitrogen is attached to the para position of this phenol, so it is called as orthonitrophenol. In the orthonitrophenol, actual structure is like this. Now, what happens? Hydrogen atom stuck between two electron negative atom, that is oxygen. So there will be a formation of H bond in this example. Alright. An interesting observation about the nitrophenol is that orthonitrophenol is more volatile than paranitrophenol. See, we have two different compounds. One is the orthonitrophenol. In the orthonitrophenol, H bond is there, which is of which kind? It is intramolecular. And this H bond, which is in paranitrophenol, in the paranitrophenol, because of the geographical separation of the hydroxy and nitro group, there will be no H bond formation within the molecule. So here in this case, H bond will form in between the molecule, and this is the example of intermolecular. This is intermolecular H bond. In the intermolecular H bond is formed between two molecules. Whenever bond, we develop a bond, whenever bond is there between the molecule, force of attraction between them increases. And when force of attraction increases, their vapor pressure or their volatile nature decreases. So, more H bond, more attraction, less vapor, less volatile. In the paranitrophenol, there is a intermolecular H bond. Therefore, it exists as a dimer or the associated molecule. Due to the association of molecule, molecular weight increases and boiling point also increases. Here molar mass is just twice 2 into molar mass of the orthonitrophenol. So when molar mass increases, boiling point also increases, because molar mass is somewhat related with the attraction between molecule. When attraction between molecule increases, molar mass increases. Molar mass increases, boiling point increases. That was the paranitrophenol. But in the orthonitrophenol, there is an intramolecular H bond between the molecule, and therefore there is no further association among the molecules, because molecules are engaged with themselves. Bond is formed within the molecule. So one molecule is less interested in the another molecule because bonds are formed within. So here molecular weight remains same and boiling point does not increases too much. Thus the ortho form has low boiling point and more volatile. Less boiling point, more volatile. I can give you the relation. Boiling point is proportional to 1 upon volatile nature, or you say proportional to 1 upon vapor pressure. They are just reverse of each other. Vapor pressure and boiling point, they are reverse of each other. Now effect of the inter and intramolecular H bond. What are the consequences? As a consequences, hydrogen bond affects several physical properties of substance like molecular state. In case of H bond, molecular state becomes different. Melting and boiling point increases. Greater the force of attraction between molecule, greater will be the melting point. It is quite obvious. So this H bond increases the melting and boiling point. But what is the effect on physical state? What do you think about the physical state? See student, physical state has a clear-cut role which is developed by the H bond. You know, we have three kinds of substances: solid, liquid and gas. if I ask you a very simple question that why solid is solid, what is the reason behind that it is solid? The reason behind it is solid is force of attraction. Solid has more force of attraction than liquid, and of course liquid has more force of attraction between molecule than gas. So physical state changes because of H bond. Because of H bond, force of attraction increases. This increased force of attraction causes change in physical state and also solubility. More often, those compounds which form H bond with the solvent, they are easily soluble. Like ammonia is very much soluble in water. Why? Because ammonia can form H bond with the water. So those substances which can form H bond with the water are more soluble in water. Like I said, molecular state, intermolecular H bond result in the formation of bigger units, sometimes 2 units or 3 units, and sometimes many more. In case of the acid, 2 molecules of the acetic acid, CH3COH, they can associate through intermolecular H bond between the molecule and they form dimer. In this case, if you calculate, its molar mass will come 120, while the molar mass of acetic acid is just 60. But because of this H bond, they dimerize and their molar mass increases. Melting and boiling point compounds containing H bond, they require high energy to break these bonds because of this H bond, and they have abnormally high melting and boiling point. So please remember this point, that H bond increases melting and boiling point by increase in force of attraction between molecules. These are few examples. They are very good examples and very important also. See, in the group 15, boiling point and as well as melting point of ammonia is exceptionally high than rest of the members of family. Why is that? You see, melting point is exceptionally high, although boiling point of ammonia is still lower than antimony, but then also it is higher than PH3 and ASH3. Can you give me the reason why? Because these three, they cannot form H bond, no H bond, but in ammonia H bond is present, because of which MP and BP both increases. The same happens with the oxygen family, and the same happens with the halogen. The same thing happens with the halogen, and the same thing happens with members of the oxygen family. Because first member, here only H2O can form H bond, rest cannot form H bond. Here also only HF can form H bond, HCl, HBr, HI no H bond. So their melting and boiling point are less. Then physical state. Have you ever imagined that water is liquid while H2S is gas? Although molar mass of water is still just 18, while the molar mass of H2S is 34, which is almost twice of the water. But then also water is liquid, but H2S is gas. So what kind of force is responsible for this? This is again because of the presence of the intermolecular H bond in water molecule. Because of this H bond, force of attraction increases and boiling point also increases. The water molecule take part in the H bond due to the presence of high electron negative oxygen atom. The water molecule unite together through the intermolecular H bond to form an associated molecule, and therefore it is liquid at ordinary temperature. So why H2O is liquid? Just because of H bond. But H bond is not possible in H2S. You already know why. Because to form the H bond, we need high electron negative atom. Sulfur is not very high in atom, so this will not participate in H bond formation. This H bond formation also affects the solubility in water. A compound is more soluble in solvent, which it can form H bond. Those solvent or those solute which form H bond with each other, they are more soluble. Lower alcohols, they are soluble in water. In fact, I should say they are very much soluble in water because they can form H bond with the water molecules. Many other covalent compounds like acid, glucose, urea, honey, they are also very much soluble in water, and the reason is same for all. They have ability to form H bond with the water. So this was about the H bond, students, and this was about the end of this unit. In the next class, I will tell you about the previous year's questions. In the next class, I'll tell you about the previous year's question which came in examination from this chapter, chemical bonding. So this is the end of chemical bonding, and we shall continue practicing questions in the next session. Till then, take care, keep coming, and keep studying. Thank you.